Okay, before we get started with the presentation, if at any point during the webinar you have any questions, feel free to type it in the chat and I will try my best to address them at the end. After the presentation has concluded, all participants will be emailed a recording of the webinar. So now I'm just going to introduce myself, the presenter, and the topic of this webinar. My name is Trinity Pham. I am the marketing coordinator at TC Communications, and our presenter today is Steve Craig, VP of Sales and Marketing. And today he will be discussing seamless link migration for analog to digital radio systems.
All right, thank you, Trinity. Welcome to everybody. I see we've got a few just coming on as we speak. Hopefully you won't miss too much at the beginning of this. Okay, so today we're going to discuss link migration for analog to digital radio systems. In previous webinars and a lot of our material, we discuss moving from analog radio systems through to analog over IP systems using our JumboSwitch. What we've not covered a great deal is using our JumboSwitch as the core IP network for digital radio systems. And on that basis, the migration from analog through to either directly to a digital radio system using JumboSwitch as the IP backbone, or through the analog over IP as a transition while you are moving towards a digital radio system. So let's look at a couple of radio systems. We're actually going to cover 4 cases on this, 2 of which we're going to cover in some detail, and 2 with a little bit less. They're fairly rare instances that we see. The most common, and for those of you who follow TC Communications will know that we spend a lot of work using converting analog systems connected via leased lines. Here's a very simple radio system topology for that, and that's the first one we're going to look at. The other one we see a lot of now, particularly as channel banks are becoming more and more difficult to get, hard to support, and obsolete. Many of those manufacturers have exited the market, and so we're seeing a lot of customers looking for a solution to replace their existing channel bank solutions. Let's look at the reason for that. The primary reason for this is lease lines, which have historically been the major means of connecting radio systems together, either using 4-wire E&M or using T1. These are becoming less and less available. And where they are available, they're either expensive or unreliable, or if you're really lucky, expensive and unreliable. And this is being driven by Verizon and AT&T chiefly, although some other providers of copper lease lines. And the reason for that is some years ago, they petitioned the FAA to allow them to retire all of the copper infrastructure throughout the US. The FAA granted them the capability to do that as long as they provided a replacement for phone services, which they're doing using voice over IP. Unfortunately, that left a lot of people, particularly two-way radio users, in a position where those lines are going away and a voice over IP solution is not suitable for connecting two-way radio. And so we're seeing a lot of that. Verizon is on a 7 or 8 year plan. They're about halfway through it to retire all of their copper lease lines. AT&T are doing a very similar thing, either telling customers that their lines are going away, they're very expensive, and certainly neither of these will offer you new copper lease lines. And of course, the drive towards digital migration. All digital radio systems are inherently natively IP. And so when you come to put digital radio system on your radio sites, you will definitely need some form of IP network, and that's what we're going to primarily focus on in here. Not only how you can use the JumboSwitch for that, but also the capability for the migration to keep your system working well and reliably, getting rid of leased lines, so that when you're ready for P25 or another digital standard, that you have a IP solution that has the capability to support all your needs. So throughout this, when we talk about the JumboSwitch, for those of you not familiar, this is a mission-critical IP solution. As you can see, it has a wide range of interface cards. We're gonna cover 3 of those, but also there is a management, what we call a management card here, which is the core of our Ethernet solution. And you can see that there provides a up to 2.5 gigabit Ethernet, can be used in either as a bus or a ring formation. And as I mentioned, mission critical, so completely solid state, no fans and so on, high temperature. We'll cover some of those features later on, but this is an industrial hardened mission critical IP solution. So let's just talk about, I mentioned 2 of the radio systems before, analog systems with leased lines and channel banks. There are a couple of others we see a little bit less, or actually quite a lot less. The first one is an analog system connected via V.24 serial. Those of you who have Motorola Quantar radio repeaters will be familiar with that, and we'll cover how to use the JumboSwitch for that to provide a more robust and reliable IP solution. And another one for you, some of the analog, particularly some of the phase 1 P25, which were actually connected natively via T1, and we'll just cover how you would do that as well. The primary focus, though, will be on the analog system via leased lines and using channel banks. Let's talk about a migration path, and often when we think about moving from analog, we think of a large forklift coming in, taking all of our analog systems out and our brand new digital system coming in. And of course, that will be absolutely fantastic. But the reality is that digital systems take quite a significant amount of time to roll out. And we are seeing as well a lot of our customers choosing to keep a number of analog channels, either for interoperability or backup or overflow capability. So what we see as a migration path is as follows, or a very common migration path is as follows. The first time we talk to people regarding this, it is around lease line replacement, and by doing that, once you replace lease line replacement, you then go to an analog over IP solution. And that means that the lease lines have been replaced with a more modern and robust IP solution. But essentially, what you end up with is your analog system just as you had before, but with a more reliable means of lease line. We also see that the primary reasons for doing this are, number 1, cost, number 2, reliability. Not necessarily in that order, sometimes for reliability and for cost, but most customers will find that replacing their lease lines with a more modern IP-based solution will mean that they gain great more reliability and for cost, and significantly reduce costs. Some of you will have seen the video we've done on the city of Rockford, Illinois, where by doing this, they have had a 56 link or 56 lease line solution. They save $4.8 million over a 5-year period doing this. Of course, some do a direct analog to digital transition, and again, need an IP solution for that. But as I mentioned, what we are also seeing is a lot of people doing a step-by-step, either replacing their leased lines and doing analog over IP, or when they go to a digital solution, keeping their some of their analog channels, and they need a solution to connect those analog channels, and they typically do that analog over IP. So this is the migration path that we see. And key to that is obviously your IP network. And why should you use JumboSwitch? Well, you need something that is both mission critical and super robust, but has the capability to maintain things, and as you'll see in this, to maintain the connectivity of your existing analog system. So let's talk about lease line replacement. Some of you who follow TC will have seen this a lot, so I'm going to go through this relatively quickly. If you would like to learn more about it, there are videos specifically on this, but this is not the primary focus of this webinar. So here we have 4 sites, each with a single channel, going back through a voter and a dispatcher. This is, I guess pretty typical. Obviously, you would have some sites that probably are just receive-only sites, but this is just for illustrative purposes. So we want to take away the leased lines. And so what do we replace it with? Well, in this case, we use the product on the right, the TC3846-6. This is a 4-wire E&M. It has up to 4 channels per card. And as you can see, you simply connect that to your repeater. Connect your 3846-6 to the IP network. At the voting end, you would use another TC3846-6. In this case, it will have 4 channels talking to the voter. And basically what this does is it simulates the leased lines. So as far as your system is concerned, there is no requirement for any changes in your network. You don't need to change your repeaters, you don't need to change your voters, it'll just all work the same way. And the IP network that you will be using in this case, you can use a JumboSwitch one. There's nothing to stop you using a third-party IP network should you have one available, but if you don't, then you'll see through this presentation that the JumboSwitch is is an excellent choice for this. And as you can see here, the key thing down on this diagram below is that not only can you set up using the JumboSwitch with either a ring or a bus-based topology, but the benefit of the JumboSwitch is it inherently has all of these different interface cards available for it, so that you can do what we're showing here, or the transitions we're going to be showing on other systems afterwards. So let's just talk about the 3846-6. Hopefully not too much for the people who have seen this before. As I mentioned, 2-wire, 4-wire E&M over either 1, 2, or 4 channels in a single card. Key feature for this, for your analog system, is completely uncompressed audio, so no digitalization of the audio. It means you get completely flat audio response, gives you that great analog audio across there, and most importantly passes your in-band audio signaling. So your guard tones, your key up tones, and so on, all of those will pass through seamlessly. Unlike some that use digitization, they will use a lot of compression that can play havoc with guard tones and so on. Extremely low latency, so ensuring compatibility with your voting and particularly with simulcast systems. Dispatch consoles and so on, and you can see the wide range of electrical and safety standards, extreme operating temperature. I'll cover that a little bit more as well, but a true mission critical solution. We're so sure about that, we give you a 5-year warranty with this. So that was the interface card itself. I just wanted to now cover the actual, what we would call the management card, which is the core of the IP Ethernet solution. And this is our management card, the TC3840-5. This is a, as you can see here, it has two 2.5 gigabit SFPs. Those can be used to create a ring-based or a bus-based topology. And there are also additional gigabit Ethernet copper ports as well. As you would expect, as you can see with all of the different mounting options there, 4U, 2U, there's a 1U and a standalone. Each of those, the actual cards and so on, don't use the front panel ports. They use a bus on the rear of the rack, and so those ports on the front, both the SFP and the copper ports, are available for additional connectivity as well. Now, this is a full carrier Ethernet based solution, and what you can see, as with all of the TC Communications products, mission critical, fully solid state, and so on. Now, what marks this out from a, perhaps a more regular IP router is this is purpose designed to go in the very same environment that you probably have your radio shelters in. This can be rated at -40 to +80 degrees centigrade. So that means that if you do have either a non air-conditioned shelter, or if the air conditioning goes out on one of those remote shelterings, this will continue to operate. For those of you who, I'm not going to go into this in great detail, but for those of you who are looking for something a little bit faster, we do have a 10G Ethernet platform as well. So you can see this is a 2U rack. The top row is the 10G. You can see the 10G SFPs there and pretty much the center of the screen, as well as a variety of additional SFP and copper ports as well. But what makes this stand out as well is, once again, the capability to put different interface cards, which when you're doing this type of analog to digital migration is critical. So let's go back and actually look at leased line replacement, and not just from the fact that we have a product here that can do the can connect your analog radio without using leased lines as well. What we will see now, and this diagram here shows you at this point here, analog over IP. This is typically the first stage, as I mentioned before, the first stage of transition from analog to digital, and this is conversion of all of your analog channels to being able to operate over an IP network. However, of course, once you have the IP network in and you start to roll out your digital one, what typically happens is you take away some of the analog channels and replace those with digital channels. And what we're going to show that here. So what we've done in this diagram is we have removed the bottom two for illustrative purposes, the bottom two analog channels, and we've replaced those with digital channels. Now, typically in most scenarios, you actually replace more digital channels than analog channels, but bear with me on this one. What you can see here is, yes, we've removed the 3846-6s because they're no longer required, because the digital repeaters are inherently IP. Similarly, typically you're talking to your dispatcher, which again is digital. But what you can see here is you didn't have to change your IP network. You didn't interfere with anything with your analog channels. Analog channels are just simply there. So this means a very seamless and robust transition from one place to the other. As you start to put those channels in, connect that to your existing JumboSwitch IP network and remove the analog channels. Similarly, you've got capability, for your dispatcher or any other of your IP connectivity that you want. And this will show you at this point here where we have the digital capability along with the analog. Now, I've left analog channels in. Of course, if you did remove all of the analog channels, it would be easy just to continue to use your JumboSwitch connection for all of your digital channels. With channel banks, this again is a common solution that we see out there, and in this case, rather than a single radio solution in the a single radio channel, we actually have a radio site. Channel banks typically were capable of handling up to 24 analog channels, putting all of those into a single T1 link. And that's what's shown here. So this is something that we see quite a lot as well. And there's a number of ways that you can actually address this. So let's take away the T1s. We're going to replace it with a TC3845-1. This is a T1 over IP, and you can see that what we basically do here is we immediately drop in a unit that provides a T1 over IP, and you can continue to use the channel banks. Or you may say with this, well, why would I bother to do that? The channel banks are obsolete. They're hard to get parts for. They're not supported anymore. They've been in service for so long, they're prone to failure. And it's fair to say that it would be as easy in some cases to simply take the channel bank out, use, say, a 3846-6 in place of for those channels, and you would not need to then do this form of T1 changing. However, there are some cases where this is a nice scenario, and I just wanted to walk through that one itself. So let's just take a single site, a single radio site with a channel bank on it. And let's actually have a look at that in some detail. Now, as I mentioned, a channel bank can typically have up to 24 for a single T1. Some of them run multiple T1s. So if you have a dense site with many analog channels on it, a channel bank was a good solution, and you may have that as well. And so a single card to provide one or two T1s to IP is a good solution if your plan is to replace a lot of the analog channels. If you're going to replace all of the analog channels and you just for the time being going to keep the channel bank, you just want to get rid of the T1 because they're not reliable, they're unavailable, they're getting really, really expensive. I've seen people paying over $3,500 a month for a T1, and there's, obviously an IP solution would be significantly cheaper than that. So this would be one capability. However, as we mentioned before, there is the 3846-6. You could simply, that has 4 ports, so if you want, you can put 4 repeaters on a 3846-6 and then another 4 on the other one. It really comes down to how many cards that you would use in each of those cases. However, what we do see significant often is a combination of these two. And what is looked at is, well, we're going to keep let's say 2 channels in this case of analog channels. And so in that case, you put in a 3846-6, connect it directly to the IP solution. You then, for temporarily, while the digital channels are being rolled out, you continue to use the channel bank for the remainder of them, and you use a 3845-1 to convert the T1 to IP, as shown in here. And then as you change all the digital channels, and the digital channels inherently use the IP solution, you end up with this situation where eventually you end up with all of the digital channels connected directly to the IP network, the 3846-6 providing you the additional analog channels. So you can see there's a number of ways of doing this. Obviously, if you have a small number of channels connected to a channel bank, you may be better going to a 3846-6 immediately. If you have a large number, typically it's a good solution to connect your channel bank using our T1 over IP solution. Now this brings an interesting one here with this one, and the fact that we've got a lot of digital channels. I'm sure you noticed previously that there were 2 SFPs and 2 Ethernet ports on the front of our management card. So what happens if you need more Ethernet ports? Well, the answer is there's a card for that. There's an interface card that provides an additional 6 copper Ethernet ports. There's also a similar card that adds additional SFP modules as well. And you can see that if you look at the various options here, you can see that you can put multiple interface cards into these jumbo switches as well. You only need one management card when you're using this to create the IP solution. And so you can see very flexible. All the cards are hot swappable, so you don't even need to, if you want to add some more Ethernet ports, you don't even need to power your rack down. Just plug one in and you're good to go. So that addresses that. Now coming towards the end for this as well, I did say I would mention T1 connectivity and obviously V.24 as well. I think you'll see where I'm going with the T1. The T1 is very similar to that. Take the T1 links away. Again, utilizing the 3845-1 T1 over IP solution, just drop that in, utilizing the jumbo switch as well. As I said, this is a really interesting one in the fact that a fair number of phase 1 P25 solutions were available with T1 connectivity, and so this may be a good move from phase 1 to phase 2. V.24, exactly the same thing. V.24 is a serial link, exactly the same approach as before. Take away those links. In this case, we use an interface card, the 3847-3. This is a serial card. Again, simulates that V.24, puts it over your IP network, and you're ready. Not only can you utilize this for your existing equipment, but you have your IP network ready there for that as well. So just going back, just summarizing with the migration path, what we've shown here is a couple of paths, I guess, from analog to digital. What we see is a lot of desire to go from analog to digital, but also there's a time thing. I think we all understand that the digital solution, while rollouts are always expected to be faster than they actually are, that means that it does take some time, and you do need to look at what are you going to do with the analog at the time. So what we're saying here is make your system more reliable first by replacing your leased lines, lower the cost by replacing your leased lines, make it more robust by using our equipment to do analog over IP, and then buy yourself some time and give yourself a good solid IP backbone for your digital rollout. So that's the solution for there. Now, just quickly, I'm going to go through the JumboSwitch, just a couple of slides here as well. As I mentioned before, and I think just summarize as well, there are a wide variety of mounting options. Depending on the number of interface cards that you require, you would use a 4U, perhaps a 2U for 3 cards, 1U, and then right down to those of you who have a single repeater or a single voting receiver at a site, you can use a standard interface card at your site. The JumboSwitch itself, as I mentioned, is fully mission critical. So as you can see here, redundant power on everything. Even if you use the standalone chassis that we had before, that still has redundant power options as well. I mentioned temperature hardened, -40 to +80 degrees centigrade. So we have many customers who use this in non-temperature or environmentally controlled shelters. It is completely solid state. There's no fans or moving parts in this. That brings up a great deal of reliability and an MTBF of greater than 300,000 hours. Mentioned before, hot swappable, so there's zero downtime. Although there's a large number of cards in these racks, there's no reason to power down the rack to be able to take a card out or put a new card in. If you take the card out, that will be fine. The rest of the rack will continue to operate. Similarly, if you plug the card in, just that card will go through a boot cycle, and then it will start talking to the rest of the rack. And then lastly, but by no means least, an extendable 5-year warranty. So standard 5-year warranty, extendable to 10 years. We really are that confident in this product. And while we're talking about the confidence and that as well, full support as well. So not only warranty, but anything up to and including 24/7 phone support, advanced replacement spares, and so on. Okay, that brings me to the end of that. I hope that was a reasonably short, but hopefully useful presentation. So, Trinity, I'll now see if there's any questions.
Yes, it looks like some people have missed the intro announcement because I'm seeing a lot of questions regarding the recording of this webinar. After the conclusion of this webinar, all participants will receive a recording emailed to them. So moving along to the questions, the first one I have for you is, does your equipment introduce delayed audio?
No, in fact, it does delay the audio a very small amount. Typically, the additional latency is in the order of under 10 milliseconds. So not from an audio point of view, not significant at all. That is pretty critical for use in things such as voting systems and so on.
Okay. And the next question we have is this compatible with simulcast?
Yes, it is. We actually get a lot of customers using this with simulcast. Again, the low latency is really key. Doesn't introduce any distortion, particularly phase distortion on this. And with the latency, even under 10 milliseconds, it is very consistent as well because of the way it's done. That means there's a consistent delay on each channel, and that means that simulcast works just fine.
Okay, and the last question I'm going to address today is, do you have references available?
We certainly do. I mentioned one through there, City of Rockford, Illinois. That's notable for that. We have a number of them. I won't mention it here because we have we would rather, if you ask for it, we can give you people. We're more than happy for you to call any of our customers and ask how our product performed.
Okay, that's all the questions that I'm going to address today. Thank you so much, Steve.
Thank you very much. Thanks everybody for listening, and hope it was useful.